Hello children, I welcome you all for Physics 10th Standard Electricity chapter of part 3. This is the final part of the lesson electricity. The topics of today's class are as follows. First, we look at the heating effect of electric current and then practical applications of heating effect, and at last we will try to know about electric power, its formula. First, let us know what is heating effect of electric current. When we look at a room, inside it we can observe a basic things like bulb and a fan. A bulb produces light by converting electric current into heat. Similarly, when a fan works for a certain period of time, it becomes warm when you look at it. So, heating effect of electric current is defined as when an electric current passes through a conductor, it becomes hot after some time and produces heat. Let us look at some examples related to this heating effect. A bulb becomes hot after it is used for certain period of time. When we touch the filament or the bulb, we can feel the hotness. And when an electric iron is put on for a certain period of time, it becomes hot and will be ready for pressing of cloths. This gives us an idea about heating effect of electric current. Now let us look into the formula for this heating effect of electric current. It is given by energy is equal to power into time. In the symbolic form, we write it as H is equal to P into T. H stands for heat energy, P represents the power, and T stands for time. As we know, P or power is given as V into I, that is potential difference into current. So, heat energy or heat effect is given by the formula V into I into T. Next, we have to move on to the Joule's law. This was given by the famous British scientist James Prescott Joule. This is called as Joule's law of heating effect. Joule's law states that the heat produced in a resistor is directly proportional to the square of current for a given resistance and directly proportional to the resistance for a given current, also directly proportional to the time for which the current flows through the resistor. When we look at the formula, it is given as H is equal to I square R into T. In this formula, H represents the heating effect, I stands for the current flowing through the conductor, R represents the resistance of the conductor, and T is the time for which the current flows through the conductor. Remember the formula once again. It is H is equal to I square R into T. Let us recollect Joule's law of heating effect once again. It is directly proportional to the square of current for a given resistance and directly proportional to the resistance for a given current and also proportional to the time for which the current flows through the given resistor. Next, we have to look at certain practical applications of heating effect of electric current. There are various electrical appliances which convert electrical energy into heat energy. Some of the electrical devices which work based on this heating effect are iron box, electric toaster, electric oven, kettle and electric heater. Out of all these devices, we shall look into electric bulb and fuse which are related to your syllabus. When you look at an electric bulb, we see the glass covering over it, and inside that there is a thin filament made of tungsten, and argon or nitrogen gas is filled inside the electric bulb. When electric current flows through an bulb, the tungsten filament present inside it gets heated up and it produces the light. This filament is made from tungsten. Why tungsten filament is used inside a bulb? If we look at it, offers high resistance and produces more heat. It also has a very high melting point. And why argon or nitrogen gas is filled inside the bulb? It is because this do not react with tungsten metal. The next important device that works on heating effect is electric fuse. An electric fuse is a safety device as it protects all the electrical appliances from high voltage of electric current. We can now look at a basic diagram of electric fuse. It has two metal caps at the ends and we have a glass tube in the middle which is vacuum, that is the air inside it is removed. We can observe a basic diagram of electric fuse. Let us now try to understand how does a fuse work. Fuse is always connected in series with the live wire. It is made from an alloy of combination of metals such as lead and tin. These metals have low melting point. That is why they are used in these fuse wires. When larger current flows through these wire, it melts and breaks the circuit, protects the electrical devices from getting damaged. It is available in different ratings starting from 1 amperes to 10 amperes. For an electric iron which consumes 1 kilowatt of power, it operates at 220 volts of domestic voltage. There, the fuse used will be of 4 to 5 amperes. These are some of the practical applications of heating effect of electric current. The last part of this electricity chapter is about electric power. The rate of doing work is called electric power. It is also defined as the rate of consumption of energy. It is given by the formula P is equal to W by T, where P stands for electric power, W is the work done, and T stands for the time. The other formula of power is given as P is equal to V into I. As we know from Ohm's law, I is equal to V by R. When you multiply this V into V by R, we get it as V square by R. And then again, when you multiply and divide by R, we get it as I square into R. This also is the formula for electric power which is used in solving the numericals. The SI unit of electric power is watt. Remember this. Watt is defined as the power consumed by a device when it carries 1 ampere of current and operated at a potential difference of 1 volt. Remember this important definition of watt. It is named after the scientist James Watt. Watt is a very smaller unit of measuring electric power. In actual practice, we use a much larger unit of measuring electric power, that is kilowatt. 1 kilowatt or kW is equal to 1000 watts. The practical unit of measuring electric power is kWh, which means kilowatt hour. You would have observed this in electric meters. 1 kilowatt hour is equal to 1 kilowatt into 1 hour. As we know, 1 kilowatt is 1000 watts and 1 hour is converted into seconds, that gives us 3600 seconds. When you multiply this, we get 3.6 into 10 to the power of 6 joules. Remember this value of 1 kilowatt hour. It is important for 1 mark question. Remember, 1 watt hour is the energy consumed when 1 watt of electric power is used for 1 hour. So this completes the today's class. Now let us look at the homework part. It is based on today's terms that we have learned. There are 5 questions in today's homework. First question is, what is heating effect of electric current? The second one is, state Joule's law. This statement you need to write and by heart it along with the formula. It is important for solving the numericals. And the third question is, what is electric power? You have to define the term electric power. Fourth one is, what is an electric fuse? And the last one is, define 1 watt. Thank you.